So, today we're diving into heat treatment, a process that's literally been shaping our world for centuries. But now it's right at the center of a new kind of industrial revolution, one that's forging this incredible partnership between human experts and artificial intelligence. And that brings us to the big question right out of the gate. Can an algorithm, a bunch of code, truly master a physical craft? We're talking about a skill that for the longest time has been all about intuition and hands-on experience. Can a machine really replace that? Well, that's what we're here to figure out.
For most of its history, heat treatment has been way more of an art than a science. Seriously, it's this world where an engineer's gut feeling and years of experience have been the most valuable tools in the entire workshop.
And this quote just hits the nail on the head. It describes what's called the grandfather effect. Basically, just doing things the way they've always been done. The thinking is, hey, it worked for the last guy, it'll work for me. But as the author points out, that's a lot like gambling. You're betting on the past instead of making decisions based on cold, hard facts. Okay, take a look at this. This is a classic tool of the trade, a cooling rate chart. Now, to you and me, this probably just looks like a bunch of squiggly lines. But to a seasoned metallurgist, this thing tells a whole story about how a piece of steel is going to transform. It takes years to learn how to read this right, and that's the art we're talking about. So here's the bottom line. The old way is an incredible display of human skill. It's this amazing blend of science and pure gut instinct experience. But in a world that's always demanding more precision, more efficiency, well, relying on craft alone starts to become a real bottleneck. All right, but then something new enters the scene: artificial intelligence. An AI comes with a huge promise to replace all that guesswork with the certainty of data and to turn this ancient art into a much more exact science.
And the potential here is just massive. We're not talking about small tweaks. We're talking about optimizing every single part of the process, from finding the absolute perfect temperature down to the degree to predicting when a machine needs maintenance before it breaks down. It's a total game changer for quality and efficiency.
And if you want to understand the sheer speed of this, look at this number, 4. AI models can get answers 4 orders of magnitude faster than traditional simulations. To put that in perspective, that's the difference between waiting days for a result and getting it in a matter of seconds. It just completely changes the pace of everything. And these aren't just theories, The data shows real, measurable results. We're seeing things like a 3.5% boost in energy efficiency, a 20% cut in wasted heat, and, get this, a nearly 95% accuracy rate in predicting how hard the final material will be. That is incredibly precise. And under the hood, this is some seriously sophisticated stuff. It's not just one magic AI. It's a whole toolkit of different algorithms. You've got things like gradient boosting for predicting strength, and even these wild physics-informed neural networks that actually have the laws of thermodynamics coded right into them. Each tool is picked for a very specific job. But, and this is a huge but, this isn't some simple story where the new tech just magically solves everything. AI is incredibly powerful, for sure, but it has some really important limits, especially when you try to apply it to the messy, complicated, physical world. And here it is, the single biggest problem, spelled out perfectly right here. There just isn't enough good data. See, machine learning models are hungry. They need tons of clean data to learn from. But in the real world of heavy industry, that data is super hard to come by. Furnaces are old, they're not always packed with sensors, and companies guard their process recipes like state secrets. You can't train an algorithm on data that you don't have. Which brings us to this really crucial difference. The AI is amazing at certain things, right? It can predict outcomes, search through millions of options, and spot patterns in real time. But it can't do what the human engineer does. It can't build the model in the first place, it can't tell you if a solution that looks great on paper is actually practical in a real factory, and it sure can't adapt when something totally new comes along. That still takes a person. So what does this all mean? It's not human versus machine, it's about something new. It's a partnership between that master craftsman and a ridiculously intelligent toolkit. This is the rise of the augmented engineer. This image of a digital twin is the perfect way to picture this partnership. The AI does the heavy lifting, right? It simulates every little heat flow and gas movement inside that furnace. But it's the human expert who builds that model, who checks it against the real world, and who ultimately decides what to do with what the AI finds.
And this isn't just a nice idea, it's happening right now. Check out this quote from Tata Steel. By letting the AI handle all the boring, repetitive adjustments, the actual human operators were freed up to do what people do best: think, analyze, and find creative ways to make the whole process better. The AI didn't replace them, it promoted them. So this is what the new workflow looks like. The human expert starts it all off by defining the problem, framing it as an engineering decision. Then, the AI acts like the world's fastest research assistant, running thousands of what-if scenarios. But the most important steps, 3 and 4, are back with the human. The engineer evaluates the AI suggestions and makes the final call. The human is still the one in charge. This whole partnership, it does more than just change one industry. It really forces us to think about what it even means to be an expert in this new age. This is a sneak peek into the future of all engineering. So I want to leave you with this one last thought to chew on. As our tools get smarter and smarter, what's the new definition of an expert? Maybe it's not about having all the answers memorized anymore. Maybe it's about having the wisdom to ask the right questions and the judgment to know what to do with the answers these powerful new tools give us.